This is Quick Clip 5.09, Momentum and Newton's Laws, and we've got a lot to cover here, so please hang on for the entire video. In this lesson, they ask you to calculate a change in velocity, and to give you an example of this, let's say a ball is pitched at a velocity of plus 25 meters per second and is hit by the bat, right? And so it's going 25 meters per second. There's a positive sign only because I chose to say that going to the right is going to be the positive direction. The ball is hit straight back with a velocity of minus 20 meters per second. And so it's going 20 meters per second, but in the opposite direction. So that means it's going to have the negative sign. So the positive and the negative is only going to give us an idea of the direction of the ball. So remember that velocity is not just speed, but velocity is also direction. So think of it like a number line. All right, so at the bottom you see a number line that illustrates where our speeds are. And so how much did it change? Well, we start off at plus 25 meters per second, but then it changes to a negative 20 meters per second. So since we're looking at it number line wise, you can probably see that the change in velocity is a minus 45 meters per second. So remember here, the question isn't the final velocity, that would be minus 20, but the change in velocity is minus 45 because it went from a plus 25 all the way to a negative 20. All right, next here we have the formula for momentum. It's P equals M times V, or momentum equals mass times velocity. Why the letter P for momentum? Well, M is already being used by mass, so Newton couldn't use the letter M. I read a few things saying that P was used for the word impetus, that Newton used P for impetus, meaning the energy making an object move. So that's why the letter P. All you have to do is remember that P is standing for momentum. Another aspect in this lesson is something called impulse. And impulse is a change of momentum over time. So let's say you're in a water balloon contest and you're trying to catch it without having it break, right? The water balloon's coming at you. How are you going to try to catch it? Well, you're going to not have a stiff hand, a rigid hand, and have the impact be very fast. You're going to have a soft hand and try to have the impact be very slow, right? So you're going to try to stretch out that time that balloon is striking your hand so it lands softly. So what we have here is momentum is going to equal force times the amount of time. All right, the amount of time that is in contact. So let's say we have 100 newtons, and it takes 1 second to catch the balloon, right? 1 second of contact, and so that's going to be 100 kilogram meters per second. All right, now the momentum, the 100 kilogram meters per second, is always going to stay the same because it's the same water balloon coming at you at the same speed. All right, so that's going to be the momentum of the water balloon. The force is going to be dependent on the time that you take to catch it. So let's say you take more time to catch that water balloon and you extend that period of time. That's going to reduce the force to 25 because the 100 is going to stay the same. So that's the idea of impulse. And then finally, let's have some examples of momentum problems. Here we have two Captain Americas. One is going 17 meters per second. The other is going 12 meters per second. Which one has the largest momentum? Well, since both Captain Americas have the same mass, then the one going faster is going to have the greater momentum. On the other hand, let's say we have Captain America and the Hulk both going the same velocity, however. Which will have the largest momentum? Well, the velocities are the same, so whichever one has the largest mass would then have the greatest momentum, and I would venture to say that the Hulk has the greater mass. And then finally, who will have the greater momentum? The Flash with a huge velocity, or the Hulk with a huge mass. So we have the Flash go, and then we have the Hulk go much more slowly. And so let's say the Flash has a mass of 90 kilograms and moves at a speed of 1,132 meters per second. All right, I looked it up. It comes to a momentum of 101,880 kilogram meters per second. Now the Hulk has a mass of 293 kilograms, and his top speed is 180 meters per second, and that comes to a momentum of 52,740 kilogram meters per second. And so you can see that here the Flash wins in the contest of momentum because of his ultra fast speed. All right, I hope that helped, and I hope you stuck it out for the entire video.